I just want to make sure because I know people, yeah, perfect, good.
Okay.
All right. Yeah, I know people have had issues with trying to advance. All right, green light, you're good to go, Arthur.
All right, thank you. Hello, everyone. Just a quick, my presentation will be a lot of the overview of what people have been talking about is how we got to the E1S 15 millimeter form factor and how kind of the thermal considerations really started driving a plethora of new storage form factors. There are a lot out there. And then finally, we will be talking a little bit about how Supermicro is adopting some of these latest new storage form factors that are coming out of the OCP community into our platforms. One of the things that we're looking at is obviously NVMe as a protocol itself is really taking over, and it will continue in the future. There's a plethora of different form factors and devices that are coming out with E1S, E1L, and U.2, and how we think about we can commercialize that for the different enterprise markets, so it becomes an easily consumable product that customers can use. Every customer has different set of requirements. Obviously, the mega hyperscalers, which some people are hearing about today, have very different requirements from tier 2 cloud or even the Fortune 500, and so there's a lot of considerations in how kind of technologies and new storage devices can become easily consumable in the marketplace. This is just a quick chart looking at kind of the forecast for the SSD units by the form factors. So you can see that EDSFF will start, the projections are that it'll start gaining more traction next year going into 2024, taking some of the M.2, what was previously M.2 storage devices. And that was kind of the driving factor behind EDSFF, was to take over some of the M.2 devices. So you're really starting to see the trend there. And then this is just what was done last year about OCP SSD Future products that they would like to see, and the participants really looked at, decided the power envelope should be around 20 to 25, and then the E1S form factor kind of won out there, and then the other ones around the thickness of the width. There's kind of scattered products there. Also, looking at what was important for the users, obviously density was a big one. The airflow was also very important, and then the IOPS and the throughput. So that kind of, I think, drove a lot of the discussions around, okay, what are the best markers for thermals versus density. Also, the interface seemed to be going a lot towards the PCIe Gen 3, 4, and 5. And then this one, the last one around the responses around how many devices per system, it was skewed towards the kind of all flash arrays that we'll see, but actually we are starting to see, or we're going to make it available on our compute platform. So not just all flash platforms, but our general purpose compute platforms, which I'll go over in just a little bit. EDSFF, obviously it's an NVMe interface, and that will go for Gen 3, Gen 4, and Gen 5. It's very thermal and power efficient, and the real estate that it takes up is very small. So you can get a lot of devices within a 1U or smaller form factor. The other advantages, obviously the E1L is for capacity, and you can basically get 4 4x the number of drives you can with the U.2. Similarly, for E1S, you can get a lot more capacity than M.2s, and you can get more drives in the system compared with the leading U.2 form factor. So we really feel like the E1S is a good sweet spot to replace, or to not to replace, but as a follow-on product to M.2 as well as U.2, which are kind of the dominant form factors today. There's different connector support types, and then in the future, I think it was talked about a little bit earlier today, there's E3, which is coming out as well, which is even higher power support. Obviously, the thermal efficiency is what is driving also the E1S form factor. It's much more thermally efficient than the U.2s, and it's going to be available obviously for the PCIe 4 and 5 timeframe. So this is just what Jason from Microsoft talked about before, where he was looking at E1S 15 millimeter as the kind of the sweet spot for the kind of thermal and capacity considerations. This again shows the if you look at the one where it has the 15 millimeter device, the airflows is much lower. So in the fourth column, much lower than the other devices. Okay, this is how. So we're really looking at E1S 15 millimeter as a important product line for Supermicro, and we are incorporating it into both our all-flash storage. So some others have shown the 1U all-flash, but we're actually going to enable that in our compute platforms. And the first one that we're going to enable is a 2U 4-node compute platform, and it's going to have 6 E1S 15 millimeter Gen 4 capable drives per node. And also in that same compute platform, it will support OCP 3.0 NIC connector. So this is an example of where we are adopting a lot of the innovation technologies that are coming out of OCP, such as E1S 15 millimeter and OCP 3.0 NIC connectors, and integrating that into our general purpose compute platforms. We are still going to have a all-flash platform going forward, and it's going to integrate a variety of form factors, including the E1S 15 millimeter. So kind of next steps for us is we will continue to adopt technologies and hopefully contribute to the marketplace, the OCP marketplace, with our general purpose servers that adopt technologies such as the E1S 15 millimeter into the community. As well, we're also very interested, earlier Jason mentioned a NVMe hard drive standard. We're also going to work on that standard as well, and hopefully help develop the ecosystem for that new standard. And that's it. Questions, comments?
Hi, Arthur. This is Pekan. One question I have is on the E1.S auxiliary supply, which is 3.3 volt supply. Usually, the 3.3 volt is used for doing telemetry. For example, if you're reading the health of the device or temperature of the device. But the spec says that the maximum current drawn on 3.3 volt is just somewhere around 350 milliamperes, which seems pretty low. If you would like to do a complete readback of SSD parameters, because you have to power up different devices and read them through SMBus. From Supermicro's point of view, what are the bare minimum parameters would you like to read even when your SSD is powered off? That means your SSD does not consume 12 volt supply. It's not getting any power, but you would still like to do some read back some health status or temperature status.
Sorry, can you state the question again?
Okay. So what are the bare minimum features or health parameters would you like to read from a Supermicro's standpoint? What are the bare minimum features you would like to read from an SSD using a 3.3 volt auxiliary supply?
I'll have to get back to you on that. Maybe we can take that offline.
Do we have any other questions for Arthur? All right, if there are no other questions, maybe something for Arthur and the Supermicro team to think about, and when you guys are ready to talk more about your platforms and the availability of people to consume and test the 15 millimeter. You heard some questions earlier that we're looking for test vehicles right now. If you're outside of Facebook and Microsoft, it may not be as easy to get access to that. So certainly interested when you're going to do that.
Yeah, so these are available for samples today. There are Gen 4, these compute node platforms. They are available for sampling.
All right, if there are no other questions, thank you very much, Arthur. We're looking for deeper engagement with the Supermicro team and this work group, and thanks for sharing what you guys have been doing so far, enabling some of the OCP technologies.
All right, thanks.
So Jason, this was the last presentation of the evening. I know we're starting up bright and early again at 8 a.m. tomorrow. We've got a lot of really good discussions to go through tomorrow. So do you have any parting?
There we go. I'll just flash that back up again. So we have, I believe, 5 more presentations, and I believe one of them's a panel, the 9:35. So we have a bunch of presentations tomorrow. Everyone, you can take a look here. It should also be in your schedule by the OCP Summit. So we do start bright and early, 8 o'clock, with a presentation from Dell. So hopefully everybody found today's track very interesting and engaging. I know there were a lot of questions, and we'll have a lot more to share in the December work group as well. All right, and with that, I believe we can end early. Thank you, guys.
We can. Thank you, everyone. Appreciate it.